Okay, guys, this is 7-4 and some 7-5 at the same, ending 7-4, starting 7-5. A position vector with endpoints at 3-4 is simply the line segment that goes from the origin to the point 3-4. Okay. All right. This is a position vector U. It has endpoints at 3-4. You start at the origin, you draw your arrow so that it ends at this point. Okay. The notation of it's a little different. It's instead of a parentheses, they use these little symbols. Okay. All right. So this is vector U. We want to look at this theta. We always like to know this angle up from the x-axis, okay? We want to know that angle. And if you think about it, the tangent of that angle is going to be opposite over adjacent, right? The tangent's just going to be B over A. So as long as we know this coordinate, I can tell you the direction. Okay, I can tell you what that angle is. Okay? There's always magnitude and direction that goes along with every vector of this form. When you see vector AB, they mean it starts at 0, 0 and ends at AB. The magnitude is simply the square root of A squared plus B squared. Doesn't this look familiar? Like R squared we used to have in the beginning. We used R when we used trig. And theta is the inverse tangent of B over A, basically. Tangent of theta is B over A. All right. So here we have a magnitude of 25. And the direction is 41.7 degrees. We're supposed to find the horizontal and the vertical component. Okay. So let's think about it. How am I going to find A and B if I know all this? How would I find A? Isn't the cosine of 41.7 equal to adjacent over hypotenuse? And isn't the sine of 41.7 equal to opposite over hypotenuse? So A is going to be 25 cosine of 41.7, and B is going to be 25 sine of 41.7. Okay? Find the horizontal and vertical components. That's all we have to do. I could have told you that before I even showed you. Where is it? Oh, anyway. Sorry. Never mind. Okay. But those are the definitions. Okay, they have in the book it says A equals the U, which is the 25. A equals U times the magnitude of U times the cosine of theta, and B equals the magnitude of U times the sine of theta. You can see that right off the triangle. It's very, very similar to what we've been doing with trig when we had X, Y, and R. Okay? That's how you find the horizontal and vertical component. Let's go the other way. Let's say we have the vector drawn. Is there a way that you would be able to write each vector in the form AB? Okay, so it's not going to have the triangle drawn, okay? But vector U, okay, if I want to write that in the form vector AB, and I know that U is 5, and I know that U is 60 degrees, or the magnitude of U is 5, the direction of U is 60 degrees, then I know that A is 5 times the cosine is 60, and I know that B is 5 times the sine is 60. The X coordinate is 5 times the cosine is 60, etc. So the cosine of 60 is what, a half? The sine of 60 is square root of 3 over 2. So if I wanted to write it in AB form, I would write 2.5 or 5 halves or whatever, and 5 squares is 3/2. There's my AB form for U. What's V is a red one. Okay, V, vector V, I'd have to know, yeah, that angle is 180. The magnitude is 2. So A is 2 cosine of 180, and B is 2 sine of 180. The cosine of 180 is -1. The sine of 180 is 0. So this is -2, 0. You might be thinking, duh. I can see that the point is -2, 0. Fine, I'm just showing you that it works. W, let's see, that's 6, and they told me that the position is 280 degrees. So that's going to be 6 cosine of 280 for A. Oh, so I wrote W equals. This is for the vector W. A is 6 cosine of 280, and B is 6 sine of 280. I don't know those. I'm going to have to use my calculator for that. And when I take 6 times the cosine of 280, I get about 1.0419. When I take 6 times the sine of 180, I get about -5.9088. Right? It's not always pretty. Okay. Okay, going back to that idea of adding two vectors with a parallelogram, drawing a parallelogram, just a reminder of some of the parallelogram properties so that you realize, we're not the main thing is we're not bisecting the angles when we draw this bisector, but remember opposite sides are equal, okay? So if I have two forces of 52, 15 and 22, act on a point in a plane. If the angle between the forces is 100, find the magnitude of the resultant force. Okay, so I have two forces, 15 and 22. Okay, it's about 100 degrees from there. I'm going to estimate, let's just say about there. I have this 22, that's a little bit longer than 15. Okay, so I'm just trying to draw what I'm seeing here. Two forces act on a point in a plane. 15, force of 15, a force of 22, and those forces are, the angle between them is 100 degrees. I want the magnitude of the resultant force. What I'm going to do, I think, is just draw the parallelogram. So in other words, this is going to be 22, and this is going to be 15, and then I know that the resultant force is right here, okay? And I want the magnitude of that, okay? So what I have to use are those properties a little bit. I'm just going to call this X. They were telling me that opposite sides are equal, and opposite angles are equal. Adjacent angles are supplementary. So in other words, if I know this is 100, then I know this is 100. The whole thing has to add to 360. So if this is 100, adjacent angles are supplementary. So this is 80, 80, 100. There we go. We have 360. Okay, I know that. How does that help me? Well, it helps me because I'm going to use the law of cosines here. I want this x. I know that x squared equals, I'm just looking at this triangle now. X squared equals 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of 80. Okay, and that'll give me the magnitude of my vector. The magnitude's about 24 after I do this math and take the square root. Okay, Is that all right? Finding the magnitude of they call this the resultant. Okay, that was kind of out of order, I guess. That was probably should have been before I started talking about, but I just, the word magnitude, I don't know, 7.4 and 7.5 just kind of run together for me. Okay. All right, now we're going to talk about operations with vectors. Okay, so we have, when you add them, you just add the two first coordinates and the two second coordinates. When you multiply a constant, you multiply times both. If I want the opposite vector, I take the opposite of both the x and the y. If I subtract, just be careful, a minus c and b minus d. Okay, so if I was ask you to perform those kinds of operations, they're pretty simple. You try them, I'll put the answers up. Pause me and try them. Okay, hopefully this is what you got. If you did not get it, please look to page 338. And if you still don't get it, bring that answer to class, or bring that question to class, sorry. Okay, a unit vector is a vector that has a magnitude of 1. Well, what's that remind us of? Our unit circle? Two very useful unit vectors are defined as follows. We defined vector I as 1, 0, vector j as 0, 1. Okay, I and j, two unit vectors. One of them is 1, 0, and one of them is 0, 1. Okay, they're right here. 1, 0, 0, 1. Okay, so we call 3 then, we can call that 3i. 4 is 4j, because j is just 0, 1. Okay. So we can now call a vector in I form. We call it ai plus bj, where I equals 1, 0, and j equals 0, 1. Okay, there's a dot product of two vectors. Sometimes it's called the inner product, and they're used to determine the angle between the two vectors. Okay, they're also used a lot in physics, the dot product. Okay, so this is how you multiply two vectors. You take a times c plus b times d. That's the dot product. It's just one number. Okay, so the dot product here is 8 plus negative 3. Okay, we just get 8 plus negative 3, which is 5. Here we get negative 12 plus 12, which is 0. Okay, that's just the dot product. Now, the geometric interpretation of the dot product is a little different. We have the cosine of theta equals dot product divided by the magnitude of each. Okay? To find the angle between these two vectors then, I'm going to take the dot product. What would that be? 6 plus 4, that's 10, divided by the magnitude of u, would be the square root of 3 squared plus 4 squared, 9 plus 16, the square root of 25, which is 5, times the square root of 2 squared plus 1 squared, the square root of 5. Okay, so that's what the cosine of theta is. The cosine of theta equals that. So if I take the inverse cosine of this, I end up getting about 26.6 degrees. Now I know the angle between those two. Okay, try this one and see if you get 90 degrees. Okay, try that one and see if you get 90 degrees. Okay, guys, oh yeah, we are done. I know that was fast. I will be going over a lot of this in class as well. I just wanted you to have a good overview. I know that was a lot of listening. We'll be doing some practicing problems in class. All right, see you then.